All right. This one at first looks pretty confusing. If I gave you a single wire and I asked you to find the B field, could you do that? Well, you should be able to look through your formulas and know, and I mentioned this also when we were talking about this section, what is the equation to find a B field a certain distance from a wire? It's not on your formula sheet, it's in your notes.
MVQR?
That is the equation to find the magnetic field at a certain distance away from a wire. And then mu is 1 times 10 to the minus 7. Okay, it's like something like Tesla meters per amp or something like that. So this is part A, and that's part B. So we have to find the magnetic fields at those points. Now, let's see if we can remember. Turn this back on. So for part A, that long explanation, which you do not hear if you're just looking at this on video, is that the outer conductor doesn't matter. And remember, again, that's because there's no electric field inside a conductor. And if there's no electric field inside a conductor, there can be no magnetic field inside a conductor. So the inside is by itself. So for part A, I just use this equation. So I literally just plug in mu times 0.6 over 2 pi, 2.5 times 10 to the minus 3. And that will give me my answer. Now for the outside, it's a little bit more interesting because there are Okay, so once again, remember Gauss's law says that the charge effectively concentrates in the center. So for this small inner wire, it's as if all the charge is at the center there. And for the big outer hollow wire, it also pretends as if the charge is all at the center. Yeah?
Wait, so if they're just the one next to each other, why do they concentrate in the center?
Oh, they don't actually concentrate in the center here. So what this is telling me, so there's also a Gauss's law, sort of magnetism. And that's telling me that the inside one, I can discount the out, but for the outside one, I have to count the inside one. So B total is going to be equal to BA plus BB. And then BA is obvious, that's up there. And then BB is going to be the same thing, mu, but this one is 0.4 amps, because it's the other current, and then it's going to be 2 pi times 4.5 times 10 to the minus 3 meters. So yeah, the top becomes 2.1 times 10 to the minus 6, and then the bottom one, so yeah, we corrected that. That's 3.8 times 10 to the minus 6. And then the bottom, did you get those two numbers?
So the more spread out you are, the less the smaller the
Exactly, yeah. And since this is positive, I subtracted this. That means the final resultant is like this. That's B total.